Okay, so what's up, guys? This is Akshay here, and let us continue with the next question of our LeetCode purity question. Today's question is again an easy category question. The question name is Destination City. Let us read the question and then we can think of what are the possible approaches to solve this question. Great. So again, that's day 394 in continuation of our GFG purity list. Do check out that one as well. So we have been given an array paths where paths of I has the two city names, city A and city B, which means there exists a direct path between city A to city B. We need to return the destination city, that is the city without any path outgoing to another city. It is guaranteed that the graph of paths from a line without any loop. Okay, so they have guaranteed that there would be no loop uh, in our graph formation, and therefore will be exactly one destination only. Great. So you can clearly see first path is this is your source and this is your destination, and again this is your source, this is your destination. I can say for each and individual path. Again, Lima is source and Sao Paulo is destination, right? So we went from London to New York, right? And then again this destination becomes source for the next path, and we went from New York to Lima, and then from Lima to the final destination, that is Sao Paulo, right? So okay, let us do one more dry run. Then so when we did this dry run, you have to observe something, right? That is where the logic is residing. So again, this is your temporary source, this is your destination for this current path. Again, source, destination, again source and destination, right? So you can clearly see if we start from D, then you'll go to B, right? Then B, this temporary destination will become your source for the another path, and then we'll go for B to C, and then C will, again this temporary destination will become your another source, and then your A would be your final destination, right? So the observation I wanted to show here is that at any point of time, no source will be your final destination. No source will be our final destination. This is not possible, right? Because they are clearly said in the array there are two paths, that is city A to city B, and there exist from path from city A to city B. So if there exists a path from A to B, then definitely this cannot be my FD, final destination. That is not possible. So the probability lies on this second city, right? Among the temporary destination, one of them will be my final destination. Do we get that part? Yes. So our final destination, I'm writing as FD, will be present in what to say, second uh, part of array, or second value of array, second value of paths. Yes, temporary destinations, right? So we just need to check that if my final destination, any destination which is not present in my given source, then that would be my final destination. Clearly for C, you can see, okay, C is present in our source path, so definitely this cannot be my answer. Again, B, the destination, is again present in one of the another path as source, so again this cannot be an answer. This A is not present in any source of the given available path, so this is my final destination. Similarly for A, Z, okay, it's okay. Again, iterate for destination, iterate for temporary destination, because that would be your answer. So New York, is it present in my available source given among all the given arrays? Yes, New York is present as source, so definitely this is not my answer. So again, Lima, so this destination is, does this present as source in the available paths? Yes, I can see it. So again, Lima is also not the answer. So again, Sao Paulo, maybe I hope I'm pronouncing it correct. Okay, so this is not present in any array as source, and this will be your FD, final destination, and that is your answer as well. Correct. Now please try to pause the video here, try to code this solution, because that's a very easy one, right? So method one will take you O of n square, right? That you will iterate, you will take O of n to iterate in each and every destination, and you will again take O of n to check in all the available paths it's present or not, right? So it will be O of n square, O of 1 as space complexity, right? So how can we optimize it? So what is the repeating steps we are doing? This is the repeating, and we are doing, we are checking, we are traversing in each and every part to check if my temporary destination is present or not, right? Can we do this searching in O of 1? If yes, then we can optimize it. Yes, we can do this searching in O of 1. The only condition is that we have to put all source in hash map, right? Because if all sources are already present in the hash map, then in O of 1 we can check it, right? So in that case, it will take O of n. We are just iterating for the temporary destinations path or value in every path, and again O of n would be taking a hash map, that is to storing all the current source for every path in this given array, right? That's it. Yeah, that's it. So please pause this video again here, try to code this. Maybe you are encouraged to try the brute force as well. I will not do the code for brute force. We will see the efficient one. Great. So that's the code in Java. So we have a hash set, as we said, of type string, and then we are iterating for each and every path in the given array. But we are just iterating for the source now, because we have to put the source value in our source city, you can say, source city, into our hash set. And then we are iterating for, again we are iterating in the paths array. But this time we will just check that if my destination, the temporal destination, which has the probability that it may be my final destination, right? So that's what I have named this variable as final destination. So if that destination contains in my this array, destination array, right? If that final destination is contains in this destination array, then definitely we have to return a final destination. And else, if that's not the case, you have to return an empty string. I think they have written it is okay. So they said that the path would exist, right? So definitely great. So let us hit the submit button. What is the time and space complexity again? O of n, O of let's say 2n, ignoring the constant to be O of n, and O of 1 as space complexity. Let us see the C++ code. So that's the same we have done in Java and in the dry run. So yeah, there goes the submission. Now what else? Feel asking that first of all, this is my DSA repository. You can start and fork this DSA repository to get help with source code, and there are a bunch of standard questions here. So definitely start it or fork it. What else? So we are also covering one sheet. So I have done multiple questions, like it was day 391 on GFG POTD playlist, right? So I have curated some bunch of standard questions, total of 194 from LeetCode, right? The links are also attached. So we will be covering this playlist now. So bit manipulation I've already posted on my channel. So the next will be, I'll be posting by today or tomorrow, the maths algorithm. And similarly, we'll cover this because the market needs are changing. There is tons of hiring going on. Let us revise the concepts again, the needy concepts again, and then we can go for it. Okay. So if you like my channel, understood the problem and solution, do like, share, and subscribe. Until then, guys, keep learning, keep growing the pie, and take care.